So the next part is alkynes. So alkynes, the general molecular formula CnH2n minus 2. So alkynes are the organic compounds having carbon-carbon triple bond, isn't it? Okay. So the very first alkane that has two carbons. So if we give the value for n as 2, we get what? C2H2. C2H2. That is the very first alkyne. Okay. And the structure of that very first alkyne will be C triple bond C. With these two carbons, we should have two hydrogens. So C2H2, CH triple bond CH. Okay, right. And if you give the value for n as 3, you will get C3. Yeah, for n 3. So 2 into 3, 6 minus 2, 4. So C3H4. C3H4. So 3 carbon atoms. So C bond C bond C. So since the compound falls in the molecular formula C3H4, so it comes under CnH2n minus 2, it must be an alkyne. Okay, so alkynes are compounds having carbon-carbon triple bond. Okay, so you can add the triple bond here or here, C triple bond C, C. Both are identical. So valency of carbon is 4. So here I had one hydrogen. For this carbon, for this middle carbon, already 4 bonds are there. So the valency of carbon 4 is satisfied. And for this corner carbon, already 1 bond is there. So what? CH3. Okay, so in this structure also, here CH3, here CH. Okay, so this is the alkyne that has 3 carbon atoms. Okay, and alkyne with the 4 carbons. So if you give value for n as 4, you get what? C4. And what about hydrogen? 2 into 4, 8. 8 minus 2, 6. So C4H6. So this is the alkyne having 4 carbon atoms. So 4 carbon atoms, carbon. Okay. And triple bond. Here there is a chance for triple bond at 2 different positions. You can give triple bond at the corner, either at the corner or at the middle, here, middle. Okay. If you give triple bond, this corner means it is identical as that of first one. It is same as that of first one, isn't it? Not same, it is identical. We should say like this only. Okay, right. So these two are different. Okay. Can we write any more compound with the molecular formula C4H6? Can we? No. Okay. You can't add 1 carbon in the branch also. If you had 1 carbon in the branch, then valency problem will be there. Okay. So only two alkynes can be written with the molecular formula C4H6. Okay. Shall we fill the hydrogen atoms? So with this carbon at corner, there are 3 bonds already, so we give 1 hydrogen. For this carbon, already 4 bonds have been satisfied, so no need to give hydrogens. This carbon, 2 bonds. 2 bonds means what? H2. This corner carbon has 1 bond, so what? H3, isn't it? Right. Here, 1 bond means H3, 1 bond means H3. For this carbon, already 4. This carbon also already 4 satisfied. So that's all. Okay. So we have written 2 different alkynes with the molecular formula C4H6. So compounds having same molecular formula but different structural formula, different structures are said to be isomers. So these two are isomers since they have same molecular formula C4H6. Okay, right. So what is the difference between these two? These two differ in their structure. Actually, position of double bond is changing. So yeah. Position of the double bond is different in these two compounds. They are isomers. What type of isomers? Position isomers. Okay, we will see about isomerism in the later classes. Okay. Let us write common names for these alkynes. Okay, already we know that this is the alkyne, simplest alkyne. Okay, we know that C2H6 is ethane, C2H5 is ethyl group, which is alkyl group, C2H4 alkyl group minus hydrogen is alkylene. Alkyl group minus hydrogen, alkylene. Alkane minus hydrogen, alkyl. Okay. Alkane minus hydrogen, alkyl. So C2H6 minus hydrogen means C2H5 bond. That is alkyl. So ethane minus hydrogen, ethyl. Alkyl group minus hydrogen, it is alkene. It is what? Alkene. Okay. So the name, common name should be ethylene. Ethylene. Now we remove two hydrogens from ethylene. Then we get what? One alkyne, which has triple bond between the carbon atoms. So the common name for this alkyne is acetylene. What? Acetylene. C2H4 is ethylene, C2H4 is ethylene, C2H2 is acetylene. What? Acetylene. C2H5 is actually ethyl group. Ethyl group. C2H6 is the alkane. Its name is what? Ethane. So ethane, ethyl, ethylene, and C2H2 is what? Acetylene. Among these four, ethyl is the group. Other three are compounds. Other three are compounds. Okay, fine. Okay, so for other alkynes, we should give the common names based on the acetylene. Based on the acetylene. Okay, if you see acetylene, there are two hydrogen atoms. If you see this compound, one hydrogen from acetylene has been replaced by what? Methyl. So this looks like acetylene, but it has methyl group instead of one hydrogen at one end. Okay, this also identical. Okay, so instead of one hydrogen in acetylene, methyl group is there. So this is methyl acetylene. This time already we have seen, isn't it? So methyl acetylene. Okay, so this is methyl acetylene and this is CH3CH2, nothing but C2H5. Simply this can be written as what? C2H5. So this is ethyl. This part looks like acetylene. So ethyl, this is acetylene. So ethyl acetylene. Ethyl acetylene. Ethyl acetylene. So this is the common name. Okay, and for the last compound, this part looks like acetylene. Instead of two hydrogen and two ends, two methyl groups are there. Two methyl groups are there. So methyl acetylene. Methyl acetylene. This is dimethyl acetylene. Dimethyl acetylene. So in general, the general name or common name for alkynes are given in terms of the very first alkyne, that is acetylene. That is acetylene. Okay, right. And shall we give their IUPAC names? Okay. So in IUPAC names, usually the very important part is root word. Root word is based on the number of carbon atoms, already we know. Okay. So based on the number of carbons, we have to choose the root word 1, 2, 3 like that. Sorry. Yeah. Okay. So that the name alk is written and it is taken as a root word. With alk, if the compound is alkyne, now the suffix "-ine" should be added. If there is any substituent groups, that should be placed before the root word. Okay, that is a general IUPAC name. Generally, the IUPAC name will contain these things. Okay, let us see compound by compound. The first alkyne is acetylene. So the root word, it has two carbon atoms. So it is eth or eth. This is the root word. And triple bond means ine. So eth plus ine, ethine. There is no substituent at all. So simply ethine. So ethine. This is ethane. This is ethene. This is ethine. Ethane, ethene, ethine. Ethane, ethene, ethine. Okay, right. What about methyl acetylene? It has three carbon atoms. So the root word is prop. Okay. Triple bond is there between carbon number 1 and 2. Okay. So prop, first carbon has between first and 2, triple bond is there. So since 1 and 2, the list number 1 should be actually written. But in this case, it is no need to write what? 1. So yeah. So simply propine enough. Simply propine. Propine. Okay. Because there is no possibility of writing the triple bond other than first position. That's why the number 1 is omitted. Okay, fine. So the next compound is ethyl acetylene. Ethyl acetylene totally has how many carbons? 4 carbons. So being 4 carbons, the root word is what? Bute. Okay. So let us give numbers. So numbering 1, 2, 3, 4. If you start from this end, this triple bond will be placed. It is placed between 1 and 2. If you give numbers starting from here 1, 2, 3, 4. Now triple bond gets the number 3 and 4. It is placed between 3 and 4. Which should be correct? Always the functional group or double or triple bond should get what? Least number. So yeah. Okay, so this is correct, this is wrong. Okay, okay, so 4 carbons, the root word is but, triple bond means ine. Should we compulsorily write the number? Since the double bond is between 1 and 2, should we give the number 1 compulsorily? Should we? Yes, definitely we should give, because the position of triple bond may change. You just see this compound. In this compound, the triple bond is placed, it is present between second and third carbons. So, yeah. So since there is 2 different compounds in this C4H6 molecular formula, we must mention the position of triple bond. So the name is but1-ine, but1-ine. So ethyl acetylene, IUPAC name is but1-ine. What about dimethyl acetylene? So you can start numbering from anywhere, from any end. So yeah, the triple bond will get the same number. Okay, right? 1, 2, 3, 4, 4 carbons. So the root word is but. Since the triple bond is present between 2 and 3, the list number 2 should be written. For triple bond, the name should be ine. The IUPAC name will be ine. So but2-ine. So this is but1-ine, this is but2-ine. Okay, right. So we have written IUPAC names for some alkynes. Okay. So alkynes are having YNE, ine as their IUPAC name. In alkynes common name, the common names are generally based on the very first alkyne, acetylene. Okay, fine, right. So that's all about alkynes. Up to this, it is enough as of now. Let us pass on to the next group, next functional group. The next part, what should be? Halo compounds. Let us see about what? Halo compounds. Halo compounds. Halo compounds. Halo compounds. So the organic compounds containing halogens. The organic compounds containing halogen. Okay. So halo compounds. Okay. What is the general molecular for alkanes? CnH2n plus 2. Instead of one hydrogen, one halogen will be present. Instead of one hydrogen, one halogen will be present. What are halogens? Halogens are generally represented by the symbol capital X. The halogens are fluorine, chlorine, bromine, iodine. So these are the halogens generally. Okay, right. So the general molecular formula for halogens, halo organic compounds are CnH2n plus 1. That is, this part represents actually what? Alkyl group. This part CnH2n plus 2, 1. This is the general molecular formula for alkyl group. So alkyl with X. Simply we can write alkyl with X. Okay, right. Okay, let us see some compounds with molecular formula, structure, common name and IUPAC name. Okay, right. We can give values for N and halogen, anyone we can take from these 4 halogens, fluoride, FCl, Br and I. Okay, so the first halogen with only 1 carbon, so CH3X. For X, I can give any halogen, so it may be first I give Cl, chlorine. Okay, so CH3Cl. This is the structure of this halogen. Okay, so this is the very first halo compound with only 1 carbon. Okay, right. If you give value for N has 2, you get what? C2H5X. Now the structure can be C bond C. X instead of X I write what? Br. So CH3, CH2, Br. Okay. Or simply you can write what? C2H5Br. So this is the halo compound having 2 carbon atoms. Okay. Now let us give value for N as 3. We will have C3H7X. What will be the structure? C3H7 is actually the propyl group. Already we know that There is only one propane, but there are two propyl groups. The one is N-propyl and the other one is isopropyl. Okay, so by using this C3H7, I can write two different types of propyl groups. CCCX, CCCX. Okay, so one bond means H3, or two bonds means H2, two bonds means H2. Instead of X, I can give any halogen, what? F. I give now F. Okay, here I can give I. So CH3, CH3, CH. So this is one type of propyl halide. This is another type of propyl halide. Okay, right. So the next is N is equal to 4. So we will have C4H9X as the general molecular formula. By using this, from this I can write 4 different types of what? Alkyl halides. Okay, 4 different types. So actually C4H9 is actually what? Butyl group. We know that there are 4 different types of butyl groups. Okay, 4 different types of butyl groups. CCCX, CCCX, CCC in the branch X. The last one CCXCC. So these are the 4 different types of butyl groups. These are actually skeleton. They are skeleton. Okay, let us fill with hydrogens and there are some halogens. Okay, one bond means what? H3. Two bonds means H2. Two bonds H2. Two bonds H2. One bond H3. One bond H3. H2. Here what? 3 bonds means what? H. Okay. Here one bond. What? H3. Here 2 bonds. What? H2. Here 3 bonds. What? H. Corner 1 bond. So H3. Corner 1 bond H3. Corner 1 bond H3. Corner 1 bond H3. Middle already 4 bonds. Okay. Okay. So instead of X, I can replace some halogens with X. So different types of halogens. There are 4 halogens I have written here. So in the first compound, I introduce F. The second one Cl. The third one Br. The last one I. F, Cl, Br, I. Okay. So these are the 4 different types of butyl groups. Okay. Now let us give their common names. In common names, what should be is actually for halo compounds, the name should start with what? Alkyl and should end with what? Halide. Alkyl halide. And the common name is generally called as what? Alkyl halide. So these are all alkyl halides. These are their structures. Okay. Now let us give their common names. The name should be generally as what? Alkyl halide. This is what type of alkyl group? CH3. So methyl. Cl is what? Halide. The halide name of Cl is chloride. And for F, fluoride. And for Br, bromide. And for I, iodide. So the name should end with what? IDE. So Cl means IDE, chloride, methyl chloride. So the name of this, common name of this CH3Cl is what? Methyl chloride. And for this is what alkyl group? CH3CH2 or simply C2H5. So this is ethyl. Already we know that this is ethyl. So Br is bromide. So bromide. Okay. Generally halogens name end with what? INE. Fluorine, chlorine, bromine, iodine, INE. Instead of INE, we should write what? IDE. Okay. So IDE. So what about this? Alkyl halide. This is alkyl. This is halide. Now what is this alkyl? Actually, what is the name of this alkyl? This is N-propyl group, you know. So N-propyl, F is what? Fluoride. F is what? Fluoride. So this is N-propyl fluoride. N-propyl fluoride. What about this? Is this isopropyl? Yes. Whenever the name iso comes, there must be CH group which is attached with the 2 methyl groups. If CH group is attached with the 2 methyl groups, then the name iso will be there in the common name. Okay, so this is iso, totally 3 carbons. So prop, so being alkyl, it is ending with YL. So isopropyl. I is what? Iodide. So this is isopropyl iodide. Okay. Okay, so now let us write the common names for these four compounds. Okay, can you tell? These are four butyl groups. Okay, what is the name of this first butyl? Yes, very good. N-butyl. Those who have said N-butyl is correct. So N-butyl. N means normal, but means 4 carbon, YL stands for alkyl. Okay, so butyl. Okay, what about this? Sir, here CH is there with the CH2 methyl groups are there, sir. So the name iso. Very good, very good. So iso. So whenever iso comes, there should be CH attached with the 2 methyl groups. Okay, so this is actually iso, totally 4 carbons. So in the common name, you should write what? So common name should represent all the carbon atoms. So 4 carbons means but. Since alkyl group, YL. So isobutyl. Isobutyl. So whenever you see the common name, it should represent its structure accurately. Actually, the number of carbons should be what? Equal. Prop means what? 3 carbons. So 3 carbons. Prop, here also prop. So 3 carbons. Eth, 2 carbons. But, 4 carbons, 4 carbons. You have to verify accordingly. Okay, right. So this is also having 4 carbons. So but, but the name iso should not be given because this is not iso. CH is there, methyl is there, here also one methyl there. But this CH should be attached with the 2 methyl groups. The CH itself should be attached with the 2 methyl groups. But here the CH is attached with the 1 methyl, there is no another methyl. This is actually what? CH2. Okay, that's why it is not iso. Then what? What else? CH with any functional group. CH with any functional group means actually secondary. This compound is what? Secondary. So this is butyl alkyl group YL. So this is secondary butyl. CH with the functional group. Here halogens are the functional groups. So CH with the functional group means secondary. C with the functional group. Now the C is attached to the 3 alkyl groups. C is attached with the 3 alkyl groups. Okay. So C bond. If it comes like this means it is actually tertiary. So in the short form we are writing tert. Otherwise we can write 3 degree. So tert butyl. Tert butyl. So N-butyl, isobutyl, secondary butyl, tert butyl. So these are the 4 different types of butyl groups. Okay. Let us give their halide names. F for F, fluoride. And for Cl, chloride. And for Cl, chloride. And for Br, it is bromide. And for Br, it is bromide. And for I, it is iodide. And for I, it is what? Iodide. Okay, right. Okay, fine. Let us give their respective IUPAC names. Okay, right. IUPAC names for halo compounds. IUPAC names. Always the IUPAC name should contain the root word. The root word is generally taken from the number of carbon atoms. So if the compound has 1 carbon means meth, 2 means eth, like that we know that. So the root word is alk. Root word is what? Alk. Okay. If the alkyl halide contains only single bond between carbon atoms, now after the root word ane. For alkane it is what? Ane. If the alkyl halide contains double bond means ene. If it contains triple bond means ine. Ane, ene, ine. So after the root word either ane or ene or ine. Ane, ene, ine. Any one of these must be added. Okay. So before the alkyl group, we have to write the substituent groups. Okay. Here the substituent group itself is the halide. The halide here is considered, halide is always considered as the substituent group. It should not be written after the root word and the suffix ane, ene, ine. Okay. So the halide should be written in front of the root word, which is treated as substituent group actually. Okay. The substituent name for halide in IUPAC name is halo. What is halo? So the general name will be haloalkane, haloalkene, haloalkyne, like this. Okay, shall I give based on this general IUPAC name to all these compounds? Okay, fine. So methyl, it has only one carbon, so the root word is meth. So there is no double bond in the compound. So N. Okay. Since Cl is there, the halo name for Cl is chloro. So this is chloromethane. This is what? Chloromethane. Okay. So chlorine, Cl is actually chlorine. Instead of INE, we should add what? O. In IUPAC name, okay, the halo names actually how they should be written is, instead of INE in the halogen name, INE is removed by O. INE is replaced by O. INE is removed and O is added. We should be very clear in this. Okay, let us write the IUPAC name for the second compound, which is ethyl bromide. So 2 carbons means eth root word. There is no double bond, only single bond. So after eth, An, before eth, the halo name. What is the halogen here? Br. Br is bromine. In bromine, IN is removed and O is added. So brom plus O, bromo. So bromoethane. Okay, right. Okay, and for these two, N-propyl fluoride and isopropyl iodide. Okay, so in these two compounds, there is a chance of changing the position of this halogen. In this compound, F is located in the first carbon, but in this compound, the iodide is located in the second carbon. Okay, so 1, 2, 3. Always we should give the number in such a manner that the halide should get the least number. So that is, we are following the lowest locant rule. Okay, right. So if you give numbers from starting from here, F will get number 3. It is wrong actually, we know that. So we have to start from the carbon here in which F is attached. Okay, so here F is attached, so this must be the first carbon. So 1, 2, 3. So 1 fluoro, root word is prop, single bond means N. So 1 fluoropropane. Okay, va? Okay, 1 fluoropropane. What about for isopropyl iodide? You can start from any end. Okay, in both cases, the I will get the same number 2. Okay, so 2. In the second position, I is there. So 2 iodo, IDE. Instead of IDE, we should add what? O. Okay, so iodo, 3 carbons. So the root word is prop, single bond. So N. So 2 iodopropane. Okay, right. Okay, so just try and write the IUPAC names for these 4. I give 2 minutes time. Completed? Have you completed? Okay, right. Let us see. Listen, my dear students. Okay, so IUPAC name for these 4 different types of butyl halides. Okay, the first one, N-butyl fluoride. So, as per the second rule, lowest log control, we should give number 1 from here. Okay, so 1, 2, 3, 4, the longest continuous carbon chain. So first carbon has F. So 1 fluoro, 4 carbons of but, then A. 1 fluorobutane. How many of you have written 1 fluorobutane for them? Good, very good. Okay. Second, isobutyl chloride. So as per the lowest log control and the continuous longest carbon chain, we have to give number 1 from here, number 2, number 3 can be given either here or here. Both are okay. If you give here, this you can erase it. Okay. So In the second carbon, methyl group is there. In the first carbon, Cl is there. Okay. So 1 chloro, 2 methyl, remaining 3 carbons. So propane. 1 chloro, 2 methyl, 2 methyl, propane. 1 chloro, 2 methyl, propane. Okay. So first halo. Halo. Okay. Then what? Alkane part. Halo, substituent, alkane part. Okay. So 1 chloro, 2 methyl, propane. Here chloro and methyl both are considered as what? Substituents. Okay. Right. So whenever you are writing the substituents, you have to follow one more rule also. That is what? If there are two different types of alkyl groups, while writing their substituent names, we have to follow alphabetical order. You have to follow what? Alphabetical order. In alphabet, which comes first? First come first written. On this basis, you have to write. Okay. Okay. So C and M, which comes first? C. So chloro. 2 methyl propane. C comes first. Then what? M methyl. C M. Which comes first? C. So C is written first. Okay. Right. Okay, how many of you written like this? 1 chloro, 2 methyl propane. It just, very good. Okay. Next, secondary butyl bromide. So, as per the first two rules, we have to start from here. So, 1, 2, 3, 4. If you start from here, this Br will get number 2. If you start from here, the Br will get number 3, which is wrong. Okay, right. So, 2. So, in the second position, Br is there. So, 2 for Br, we should write what? Bromo. So remaining 4 carbons, so but, single bond means N. So 2 bromo butane. Okay. And what about the last compound? Tertiary butyl iodide. Numbers, if you start from 1 and 2 here, the chain has only 2 carbons. If you start from 1 here, 2 and 3, now the chain has 3 carbons, which is correct actually. So the chain should have the maximum number of carbons. That is, the first rule tells what? Continuous longest carbon chain we have to choose. We have to identify. So either from top to bottom or from bottom to top. Both are correct. In both cases, this CH3 and I will get the same numbers. So we can start either from top to bottom or from bottom to top. So I have started from top to bottom. Okay, so 1, 2, 3. In the second position, 1 methyl group. At the same second position, 1 I is also there. So 2 iodo, 2 methyl, remaining 3 carbons, so propane. So 2 iodo, 2 methyl propane. So 2 iodo, 2 methyl propane. 2 iodo, 2 methyl propane. So this is the IUPAC name of the last one, tertiary butyl iodide. Okay. How many of you have written 2 iodo, 2 methyl propane? For you, it is correct? Huh? Oh, super. Very good, very good. My appreciation. Okay, good. Okay. So, whenever two or more than one substituent groups are there, while writing the name in IUPAC, we have to follow what? Alphabetical order. Okay. In writing common names also, if there are more than one alkyl groups, then there also we should follow what order? Alphabetical order. Okay, right. Okay, fine. Now I give you a few compounds. Okay, for that, actually each and every compound has 3 names. Actually, the first one is structure and the remaining 2 are names actually. Okay, among these 3, I will give any one. You have to complete, you have to write the remaining 2. You have to write the remaining 2. Okay, shall we play? Yes. 1, 2, 3. have given two different structures. So for this, you write, I have given structure. So what you have to write is common name and IUPAC name. Okay, 2 minutes time. Fast, do it fastly. Finished. Okay, right? You see, let us write first common name. Let us write first common name and then IUPAC for the first one. Listen. So common name. Actually, this is the middle carbon. This has actually, it would have 4 groups, 4 alkyl groups around it. Methyl, methyl, methyl. This also must be, would have been methyl. Instead of 1 hydrogen in this methyl, 1 Cl is there. Okay. Actually, this is if the compound, if the central carbon is surrounded by 4 alkyl groups, not need to be different, they may be same also. Okay. So same or different alkyl groups, the name should be what? Neo. So neo, totally 5 carbons. So pent is alkyl group, yl. So neopentyl, Cl is what? Chloride. So neopentyl group, neopentyl chloride. So this group is what group? Neopentyl group. Already we have seen. Neopentyl group. In the same way here the common name. Here the common name. Common name. If C is attached with 1 halogen and the remaining 3 bonds are with 3 alkyl groups. Now this C bond Br, this part is actually tertiary. Tert. How many carbons totally? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What? Pentyl. So tertiary pentyl Br, so bromide. So tertiary pentyl bromide. The first one is neopentyl chloride. The second one is tertiary pentyl bromide. Okay, right. Let us write the IUPAC name. Okay, where the Cl is attached for this carbon, you have to give number 1. Okay, so number 1, number 2, number 3. 1, 2, 3. The longest continuous carbon chain has only 3 carbons, or 1 to 3, or 1 to above 4, 3, 1 to 3. So wherever you go, you will get only 3 carbons in the chain. So maximum number of carbons is 3 in this compound. Okay, what about here? This is 1, this is 2, this is 3. 1, 2, 3. If you go after 1 to here, 1 to only 2. If you go up, 1 to only 2. So this is the longest continuous carbon chain. Okay, let us give the IUPAC name. Okay, 1 Cl. So 1 Cl. So 1 chloro, 2 methyl. So 2, 2. How many methyl groups are there? 2 methyl groups. So dimethyl. So 2, 2 dimethyl. In the chain, 3 carbons are there. So prop, only single bonds are there. So ane. So 1 chloro, 2 dimethyl propane. 1 chloro, 2 dimethyl propane. What about the IUPAC name of this tertiary pentyl bromide? IUPAC name of this tertiary pentyl bromide. Okay, so 1, 2, 3. 1 bromo, 1 dimethyl. In the first carbon itself, Br and 2 methyl groups are there. Okay, so 1 bromo, 1 dimethyl. The chain has 3 carbons. The longest chain has 3 carbons. So the root word is prop. In the longest chain, only single bond is there. So propane. So 1 bromo, 1 dimethyl propane, isn't it? So this is what IUPAC name of tertiary pentyl bromide. Tertiary pentyl bromide. Okay, fine, right. Okay, I write some other also. The compound is, the structure is CH2 double bond CHCl. So I have given the structure. You have to write what? Common name and IUPAC. In one more. I give common name, that is allyl chloride. Allyl chloride. You have to write what? Structure you have to write structure and IUPAC. Here a given structure, you have to write common name and what? IUPAC. Okay, can you? Is it possible? Yes. Shall we write? Yes. CH2 double bond CH. This group is called as vinyl. Already we have told. If you don't know means, you please go to the hydrocarbon and alkyls video. So yeah, you just watch once again. If you don't know means, or if you didn't watch means, then you have to watch one time. Then you will know the name of the different types of alkyl groups. Okay, so this is vinyl and this is chloride. So this is vinyl chloride. This is vinyl chloride. Okay, allyl chloride. Vinyl is CH2 double bond CH. Allyl is actually CH3 single bond CH double bond CH2. This is what? Propylene. In propylene, in this methyl group, if you remove one hydrogen with any halogen, here Cl. Now this is allyl chloride. This is actually allyl part. Okay, propylene minus hydrogen. That hydrogen must be removed from methyl group. So this is allyl. So allyl chloride. Allyl chloride. Okay. Let us give the IUPAC names for these two. Okay. So for vinyl chloride, Cl is attached with the first carbon. So we have to give 1. Okay. So while giving the number to Cl, if any double or triple bond means, okay, then for which we have to give preference, either to halogen or to double or triple bond. Either in this case, either to halogen or to double bond, to which we have to give preference means, okay, after alk only, an, ene, ine are coming. Okay, so these are represented as suffix, since they are coming after the root word. After the root word means they are called as suffix. Before the root word means it is called as prefix. Always while giving the name or giving the IUPAC name, always the preference or importance or the significance should be given to what? Suffixes, not to prefixes. The importance should be given to suffixes. Okay, but in this case there is no problem. Okay, Cl and double bond both are with carbon number 1 only. Okay, so we can start from here. So 1 and 2. Okay, so in the first carbon one Cl is there, so 1 chloro, and eth between 1 and 2 one double bond is there, so 1 chloroethene. So yeah, since 1 is there, simply we can omit 1 in this case. Omit 1 in this case because there is no possibility of the Cl and double bond with the other carbons. They must be with this carbon, with the first carbon only. Okay, there is no chance for writing another structure in this name. Okay, so we can simply omit numbers. So simply chloroethene. So for vinyl chloride, the IUPAC name is simply what? Chloroethene. But in the case of allyl chloride, the Cl is attached with this carbon, but double bond is attached here. It is present here. It is present here. Okay. From where we should start numbering? From where we should start numbering? If you start from number 1 here, that means you are giving preference to Cl, that is halogen. Halogens are considered as prefix. What I have told already, the importance or the preference should be given to double or triple bonds if they come. Other than halogens. Then what? Halogens. Then what? Halogens. Okay. So if you give number 1 here, it means that you are giving preference to halogen, which is wrong actually. So we have to start numbering from here. Okay, number 1, number 2, number 3. If you give numbers like this means the number 1 will come to double bond and number 3 will go to Cl. For Cl number 3 and for double bond number 1, which is right. That means you are given preference to double bond and least preference to halogen, which is correct actually. So this is correct. Let us write the IUPAC name. So in the third carbon Cl is there. So 3 chloro, 3 carbons. So root word is prop. Between 1 and 2 double bond is there. So 3 chloropropene. The position of double bond to be mentioned. Actually. Okay. So 3 chloroprop 1 gene. Okay. Right. Clear? Okay, fine. Let us see some aromatic compounds. So with the benzene ring directly, if one halogen is attached, so benzene ring minus nitrogen is phenyl, Cl is actually chloride. So this is phenyl chloride, which is the common name, phenyl chloride. Okay, we know the structure of phenyl as C6H5 bond. Otherwise, benzene ring, which is short of one hydrogen. Okay, and what is the name of this group? Benzene ring with the CH3. This compound is actually called as methylbenzene or toluene. In toluene, if you remove one hydrogen from methyl, now this group is called as what? Benzoyl. Very good. Benzoyl. Okay. With this benzyl, if you had one Br, now this is called as benzyl bromide. This is what? Benzyl bromide, which is the common name. Let us give the IUPAC names. Phenyl chloride. The name should start with halo. So halo. Here there is no alk, it is aryl part. So aryl means ar plus arene. So here the arene is benzene. Instead of alkene, it is what? Arene. So the arene present here is benzene. So chlorobenzene. The IUPAC name of phenyl chloride is what? Chlorobenzene. And what for benzyl bromide? Br is attached with this carbon. Okay, with this carbon, Br as well as phenyl, both are attached. Okay, so the name is phenyl bromomethane. This is IUPAC name. Okay, right. So phenyl chloride and benzyl bromide. For these two we have written. Okay. Next, if there are two substituents attached with the benzene ring, Cl, Cl. Okay. Cl. Okay. Cl. Okay. Cl. Okay. Actually, I have attached two chloride groups, two chloride in benzene ring. Okay. But I have written 5 structures. Are they same or different? Actually, are they identical? I simply want to ask you, are they identical or different? Different or identical? Identical or different? Different? No. They are identical. All are identical. Okay. All are identical. Okay. In the previous classes, I have told that in benzene ring, if there are two substituent group, means if the angle between the substituent groups is 60 degree, then it is called as ortho. If the angle between two substituent is 60 degree, then it is called as ortho. In all these cases, the angle between two substituents is 60 degree. So all are ortho. All are identical, one and only. How can you understand this one? You see, if I take a selfie from my mobile, I give pose like this. And in another selfie, I give pose like this. In another selfie, if I take 5 different selfie pictures by using my mobile, and after seeing all these 5 selfie pictures, what you will say? What should I say? All are me. It's me and me only. All are identical, not different. All represent me only. That means what? It is me and me only. There is no difference in all the 5 structures. Okay. So all are identical. So all are ortho. So 2Cl. So ortho dichloro. So benzene. Ortho dichlorobenzene, which is the common name. And what about IUPAC name? In IUPAC name, instead of ortho, we have to give numbers. You can start numbers from anywhere. For one Cl, you have to give 1, and for another Cl, 2. For here also 1, 2. Here also 1, 2. Here also 1, 2. Here also 1, 2. All are 1, 2, 1, 2, 1, 2, 1, 2. Okay. So IUPAC name 1, 2, 2 Cl. So dichloro, so benzene. So 1, 2 dichlorobenzene. 1, 2 dichlorobenzene. If the angle between two substances in benzene ring is 60 degree, it is ortho. If the angle is 120 degree, it is what? 120 degree, it is meta. If the angle between two is 180 degree, it is what? Para. Okay. Ortho, meta, para. Ortho, meta, para. Okay. Right. So based on the angle between two substances. Okay. Right. So for Halo compounds, we have given structures, common name, and IUPAC. So with this Halo compounds are woven.